Hi everyone, and welcome to today's Physics Daily Booster. What we're going to be doing today is on the advanced information for both foundation physics and higher tier physics. We're going to start off by having a look at the work in Unit 8. So we're on P8, the final unit in physics overall. Now, one of the bits in P8 is a certain element of, to be fair, common sense. It's asking us some, what I would say would be general knowledge stuff, because what they can ask us to do is to name a bit of equipment that we would use to measure the distance and the time. So I would hope in most cases we could suggest that to measure a distance we could use either rulers or tape measures or trundle wheels, and to measure time, stopwatch probably comes to mind. Now, what I've got in the little table there are just some different scenarios and what we could actually use to work out the distance and the time. So obviously you don't have to remember all of these because they tend to stick to the dead simple someone running a race kind of thing. So you can always just go with a tape measure and a stopwatch in, I think, any case of a question I can think of. But let's have a look at some other examples anyway. If we want to be more accurate, we're talking about 100-meter sprints in the Olympics, for example. Then what we use is a pressure sensor to start. So on those little blocks at the starting point, here they are, then these are pressure sensors. So that as they actually release from there, it knows to start the timer. And that's how they know there's false starts as well. As they get to the end, we now break a laser, and that means we've got a very accurate measure of the time, as you know, down to 2 decimal places for a second. So obviously highly accurate, way better than someone standing there with a little stopwatch, because that has the issue of reaction times. If we think about a car on the road, obviously we've got the speed cameras, which you are no doubt familiar with, and those have actually got little marks on the road in most cases. So where you see those little painted lines on the road, they are a set distance apart. They then take 2 photos at a set time apart, and then based on the position that the car is on those lines that are marked on the road, they know the distance because they know how far apart each of those lines is. Divided by the time for the 2 photos, we get the speed. You can use a speed gun as well. Now this just uses pulses that are sent from the speed gun. So again, we time between the pulses and then we can work out the distance. If we're talking about a cyclist, then we can use the diameter of the wheel to get our distance, and then we can use a magnetic sensor to detect one rotation. And if we're thinking about any moving object at all that has a sat-nav attached to it, then that uses an electronic timer for our time, and we compare distance to 3 different satellites to give us a distance there. But as I say, tape measure, stopwatch, pretty safe bets. We then come back to 2 calculations that we've looked at earlier on. These are of course on the formula sheet, you don't have to memorise them. Speed is distance divided by time, and acceleration is the change in speed divided by time. Do notice that time is always measured in seconds, and if we're talking distance, that should be in meters. So just double check those units in case you need to do any conversions first of all from what they give you in the question. There are 2 terms that I've included here that we often don't use correctly, and there can be instances where they occur in a question. So if we're talking about precise data, that has a small range when we repeat it. Whereas accurate data, that's close to the true value. Now, this next bit is all to do with that little statement on the specification that talks about your ability to estimate certain speeds of things. So, again, this isn't something I suggest you memorise the entire table, but I would suggest that you pick up speed of sound, because that one does come up in a few different areas, and then pick one slow object and one faster object, because that then gives you a little bit of a benchmark on what speeds things go at, and you can kind of almost gauge how quickly the random thing in the question goes in comparison to that. So I would always suggest something like a person running, for example, that's your 5 meters per second, whereas a car goes at 22 meters per second. And that gives you a pretty fair estimate then of how things compare to those, and you can make a pretty good guess of the rest. This brings us very nicely onto one of these experiments that I expect you did in class, which is all about reaction times. Now remember, your reaction time is the time it takes from seeing something to a reaction, whatever that may be. Putting your foot on a brake, pressing a stopwatch button, whatever the reaction is. Now on average, human reaction time is about 0.2 seconds. And one of the most basic ways that we can measure reaction time is using the ruler drop test. So you can see what you do is you rest one arm just off the edge of a desk, making sure that obviously the hand is over the edge. And then what you do is you hold a ruler just above it. What you're going to do is drop the ruler and then someone catches it. Obviously someone different has to drop it who is catching, otherwise you know exactly when it's going to drop. And you've got to make sure things like the ruler is vertical. You've got to make sure that the distance between their thumb and the finger is the same each time. Otherwise it's not going to give you data that's going to allow for comparisons. We can obviously upgrade that. Rather than dropping a ruler and doing the conversion there, we can just use a digital model. So on a computer there are a range of reaction timers. One of the favourite ones I go to is tranquilizing sheep on the internet, so that's always quite a fun one. This leads us very nicely onto the bit of Unit 8 all about bringing your car to a safe stop. So basically how not to crash your car. What we need to know are 3 different distances for this: thinking distance, braking distance, stopping distance. If we start with thinking distance first of all, this is the distance travelled in the time it takes from seeing a potential hazard to applying the brakes. So a couple of key points here. If it's a thinking distance, it must be a distance we travel. And it is the distance we travel from the time we see the hazard to starting to apply the brake. So get your foot on that brake pedal basically. Now, because this is reliant on your reaction time, this is basically going to be affected by factors that influence the person. So that's an easy way to try to think of it, is thinking distance is always going to be influenced by things that affect the individual. So good examples here. One is that we're going to increase the thinking distance. If you've drunk alcohol or if you've been using drugs. These two, don't put them both down as 2 different options, they tend to be the same marking point. Being tired, distractions, eating or drinking, using sat-nav radio or mobile phone, again that one don't use at the same point as distractions, and increased speed. Now this increased speed, watch out for, because quite often what they do in these questions is they say, other than increased speed, give 2 other factors that affect the thinking distance. And of course people write down increased speed. Don't do it. Okay, if it says increased speed in the question, it will never be a marking point. So I would suggest that you go with drinking alcohol and distractions as a good one. Learn 3 different ones and then you're good to go on any question they give you. Distance number 2, the braking distance. Again, it is a distance. This time it's the distance travelled in the time it takes from putting your foot on the brake to the vehicle coming to a complete stop. So this one is going to be influenced by factors that affect the car. Okay, so again, watch out if it's asking us factors that increase the braking distance. Look out for the speed one again. If they've said other than speed, don't write speed down again. Then we've got icy or wet roads, poor brake condition, poor tyre condition. A cautionary note, don't just write tyre condition or brake condition, because if they've asked you to specify factors that will increase the braking distance, you need to be more specific. Notice how I've written all of these: icy roads, wet roads, poor brake condition, poor tyre condition. You've got to have that level of detail, because if you just said weather, then that could be a beautiful, clear, sunny day. That's not going to increase your braking distance. Just like if you wrote down brake condition, your brakes may be in amazing condition. That's not going to have an increasing factor on your braking distance. So remember, the poor brakes, the poor tyres, the icy or the wet roads, be specific. Again, learn 2, you'll be good on that one. Finally, that brings us to the stopping distance. Now, stopping distance is the total distance travelled from the moment the driver sees the problem to coming to a complete stop. Alternatively, we could write that as thinking distance plus braking distance. When you learn to drive, you will become very familiar with this little chart here, which is on the highway code. And this just shows us how different speeds affect your thinking distance, your braking distance, and therefore your total stopping distance. What we can see is if we actually look at this, hopefully you can see there that 9 to 15, that's a 6 metre increase, and then 15 to 21, a 6 metre increase. And what we can see is that there's a 20 mile an hour increase in speeds. So what we have is a very simple pattern that for every 10 mile an hour increase in speed, that equates to a 3 metre increase in your thinking distance. It's linear. The braking distance is not following that same pattern. If you look there, 14 to 38, then that's going to be 24 metres, and then 38 to 75 is more than 24. So what we can see is that doesn't follow a linear pattern, but it still increases. Let's look at this then in the format of a graph. So what we can see, thinking distance first of all, down at the bottom, here it is, this red line, that is linear of course, and therefore we can see 10 mile an hour increase in speed leads to a 3 metre increase in the thinking distance. So perfect straight line. The braking distance though, remember that wasn't linear, and we can see that from the fact that we get this curve in that blue line. Because stopping distance is thinking plus braking distance, then obviously the stopping distance also follows that curvature. It doesn't have a linear pattern for those two. Now, what we can see is that we are getting quite a dramatic increase, and the faster your speed, the greater the increase in the braking distance. So if we have a look at our typical speed on a motorway, 70 miles an hour, technically you should be leaving 96 metres, which is the equivalent of about 24 car lengths between you and the car in front, to be certain you can come to a complete stop without smashing into them. Very few people drive at that distance from one another on the roads, hence why we have so many crashes. So it doesn't really make much difference how quick your reaction times are, because as you can see, the vast majority of that is the braking distance. So that's the ability of the car to come to a complete stop. As always, if there are any bits from today's booster you'd like to go through in a bit more detail, you can use the P8 playlist on the channel. You can use your revision guides, and I do always recommend having a look at some of the past exam papers before you set foot in the exam hall. And then don't forget to join us again tomorrow for our next Physics Daily Booster.